Hi everybody, my name is Mohammad Reza Ashouri, and today I'm going to present unveiling some untold facts regarding Stuxnet a decade after the attack. Regarding myself, I have a PhD degree in software security and I'm very interested in performing program analysis and security fuzzing. Additionally, I have scientific reports on designing cryptographic algorithms, blockchain security testing, and web privacy. Regarding my work experience, I work as a cybersecurity researcher at CISPA and as a teacher at the University of Potsdam. Currently, I live in Berlin, and you can get more information about me by checking out my personal webpage. So please feel free to drop me an email if you have any question. Before we plunge into the technical aspects of Stuxnet, I would like to give you a brief background about centrifuges and PLCs to be sure we are on the same page. Essentially, centrifuges are machines by which uranium is enriched. In these devices, there are cylinders which spin at very high speed, and centrifugal force basically separates heavier gas particles which gets sent to the outside from lighter gas particles. So, centrifuges are controlled by programmable logic computers, or we would call them PLCs. Thus, if these PLCs cause the centrifuge motors to spin too quickly, it can cause unexpected damage to the nuclear sites. In this regard, Stuxnet was designed as a worm to infect the PLCs associated to centrifuges and the computer networks around them. Stuxnet itself actually was found in multiple versions. That being said, there has been some sort of mutation and update platform as the worm was propagating. In order to gain maximum access and execute arbitrary code at privileged levels on the target systems, Stuxnet exploited a number of zero-day vulnerabilities as attack vector. So, um, please note that it was firstly uncovered in 2010. So it could eventually propagate into nuclear facilities. Stuxnet ended up infecting approximately 200,000 computers. However, exact number are still unknown. Although Stuxnet was originally aimed at Iran's nuclear facilities, it has been mutated and spread to other industrial and energy producing facilities in various countries across the world. One of the zero-day exploits that frequently used in Stuxnet code is called MSOA-067 that famously used by multiple early versions of the Conflict worm, which is a malware that formed a botnet and exploited vulnerability in the SMB or Server Message Block Protocol in Microsoft Windows servers. Precisely, Stuxnet distributes itself through shell folders by scanning network shells and installs a file which is called dropper and schedules a task to be executed on the next day. The result of comparison between two exploit implementation in both Configure and Stuxnet shows us that the shellcode in the basically a Stuxnet shellcode is rather sophisticated and employs advanced techniques in order to circumvent the memory protection mechanism in Windows. One of which is return oriented programming or ROP. Yeah. So in addition to the SMP exploit, Stuxnet comprises an exploit for a previously unknown vulnerability in the print spooler service in Windows. This vulnerability makes it possible for malicious code to be passed and executed on a remote machine. So essentially, this exploit works by execution of malicious code when the Windows print spooler service cannot properly validate printer drivers. And this occurs during the installation of a printer from remote server. So as a result, two files, namely winstall or winsta.exe and sysnull appear on the infected machines. These two files are presumed to be printing documents in the system directory of target server Windows Server machine. However, here is the point here is that a guest user has no privilege that allows her to write inside of the system directory. But via the exploitation of this vulnerability, a thread of process spool sv.exe calls an API function which is named start.printer with parameter specifying the following information about the document to be printed. So you can see the information and the code below. The second stage of the attack employs the sysnull events.mof file. So MOF file is managed object format file. So this sort of files are often used in Windows, often used to create or register providers, events, and even categories for WMI. And under certain conditions, this file runs winstall.exe, i.e. the dropper, and it is executed by the system user, which results in the infection of the whole target system with the system privilege. So, in addition to the aforementioned exploit and few more, Stuxnet also used a couple of interesting privilege escalation based exploits that work based on a few zero-day vulnerabilities. For instance, it exploits keyboard layout files. So when Windows would load a keyboard layout, it indeed causes an array index out of bounds exception. And because the keyboard layout, when loaded by the kernel, this trick basically allows the worm to execute arbitrary code inside of the ring 0, i.e. the kernel level, right? Furthermore, Stuxnet exploit a vulnerability in Windows Task Scheduler so that when the Windows Task Scheduler would store tasks, it would validate them upon load with a CRC32 checksum, right? So Stuxnet could execute arbitrary commands with system privilege by exploiting a vulnerability, zero-day vulnerability in the task scheduler. Note that Stuxnet necessarily didn't restrict its replication just through the network and shell folders. It led another attack to target Windows systems in these nuclear sites by USB flash drives as well. So this is especially important because unlike typical computer worms, Stuxnet target machines that may not be connected to internet or any network at all. Because by the way, these systems belong to nuclear site, right? Therefore, in order to infect this sort of machines, Stuxnet has to find a way or a strategy to replicate itself through some sort of physical attack vector, right? To do this worm exploits the CVE 2010 2568 vulnerability, which impact the LNK or shortcut icon vulnerability in Windows. When we analyzed a USB flash drive infected with the Stuxnet in our lab, we found 6 files there, which you can see them in the following screenshot. In the first screenshot, right? So the first 4 files are LNK or link files. These are files that specify how the icon of other files should be displayed. The files with LNK extensions are different. Here is an example of the contents of one of them in the screenshot down below. So when a user tries to open an infected USB drive, the file with the name WTR4141.tmp is loaded and its entry point is called, right? The file indeed is a dynamic link library, DLL, which loads another file with the name WTR4132.tmp from the infected flash drive. This file indeed comprises a Stuxnet actual malicious code. So, as you know, the ultimate target of Stuxnet is um, targeting and stopping Iranian nuclear facilities or uranium enrichment facilities. So, after gaining arbitrary code execution access on this infected system in this nuclear site through a number of already mentioned exploits, Stuxnet now tries to attack uh, the Step 7 Siemens software. So, why this software? Because this software is an industrial control program that contains project files, and inside of it, Stuxnet injects its malicious DLLs and other files to the software, right? Therefore, this whole process of DLL injection allows Stuxnet to insert its commands into the one of the memory blocks in the PLC machines, right? Programmable logic controller machine that is responsible for controlling centrifuges motors, right? That result in changing the centrifuges motor frequencies in order to break the nuclear enrichment facilities down. So, apart from that, Stuxnet established a botnet and stored its encrypted configuration data, which is around 1860 bytes in a specific encrypted file in Win directory. Because as you know, the target system here are just Windows system. So this encrypted data comprises various information, so such as URLs of CNC servers, activation time, which is the time that means basically time and date after which the worm is active, and deactivation time, which is the time after which the worm becomes inactive and probably delete itself, the version of malware, and other information about the propagation and functioning, as we can see them in the screenshot here. So, as a conclusion, Stuxnet is the first PLC rootkit and it has received worldwide attention for causing physical damage in an industrial infrastructure seemingly isolated from the internet, i.e., Iranian nuclear facilities. Although the ultimate target of this cyber weapon, Stuxnet, was the Iranian nuclear facilities, it couldn't actually stop uranium enrichment in Iran. And the virus actually spread outside of Iran and it basically infected machines in the United States, Russia, and India, among many other countries. So it brings up the question, was that worthwhile compromising an entire globe computer security only to stop a specific Iranian facilities? So here was my presentation. Thank you very much for your attention and I hope you enjoy that. Please feel free to ask your question or drop me an email. Thank you.